Hello everyone and welcome back. I'm Madhu Varke and this is video lesson number 5. We continue with chapter 3, that is pair of linear equations in two variables. In today's video we will learn a new method of solving these equations that is called as cross multiplication method. Let's write down the pair of equations in the standard form. a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Now to use this method, we will have to write down the coefficients and the variables in a particular format, which looks like this. So you start writing with the variables x, y and 1. You can place equal to sign. Now on the left side of x, you will start writing the coefficients of y of both the equations. So b1, b2. Between x and y, you will write the constants c1, c2. Between y and 1, you will write the coefficients of x terms a1, a2. And towards the right of 1, you will write again the coefficients of y terms b1, b2. So you start from b term, go to c, then come to a and then b. Now you will cross multiply these terms as indicated by the arrows. The downward arrow shows the first product and the upward arrow shows the second product. After writing this arrangement, you will write down x divided by, look at the cross product below x. The first product is b1, c2 minus second product is b2, c1 equal to y upon c1 a2. Follow the cross under y, c1 a2 minus c2 a1 equal to 1 upon, follow the cross under 1, a1 b2 minus a2 b1. So after you write these terms, equating the first fraction with the third will give you the value of x. Equating the second fraction with third will give you the value of y. Since we are cross multiplying the coefficients and constant, this method is called as cross multiplication. I will now illustrate this method using an example. First we write these equations in their standard form. So 8x plus 5y minus 9 is equal to 0. 3x plus 2y minus 4 is equal to 0. After writing in the standard form, write down the coefficients and the variables as explained earlier. So towards the left of x, start writing the coefficients of y. So 5, 2, Then between x and y, we write the constant terms -9, -4, one below the other. Between y and 1, we write the coefficients of x term, 8 and 3. And to the right side of 1, we write again b1 and b2. So b1 and b2 is 5 and 2. Now placing the arrows, x upon the downward arrow is the first product. So x divided by 5 into -4 minus upward arrow is the second product, 2 into -9 equal to y upon -9 into 3 minus -4 into 8 equal to 1 upon 8 into 2 minus 3 into 5. So we have got our equations to find out the value of x and y. But before that, let's simplify the denominator. X divided by -20 minus -18 equal to y divided by -27, minus and minus will become plus 32 equal to 1 upon 16 minus 15. We can simplify this sign over here, that is minus and minus will become plus. So x upon -2 is equal to y upon, calculating the denominator, this gives us 5 equal to 1 upon 1. Now equating the first to the third fraction, so x divided by -2 is equal to 1, therefore x is equal to -2. We get our x value. Similarly, now equating second to 3, y by 5 is equal to 1 on 1, so y is equal to 5. This is our y value. So far in the chapter, we have used various methods to solve pair of linear equations. This particular question is not about finding the values of x and y. Let's read the question. For which values of a and b does the following pair of linear equations have infinite number of solutions? So here we have to find out the value of a and b. We use this information from the question that this pair has infinite number of solutions. To have infinite solution, it must satisfy the condition for infinite number of solutions, which is a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. So let's write down what is our value of a1, b1 and c1. a1 is 2, b2 is 3 and c2 is 7. Similarly, writing the values of a2, a minus b, b2, a plus b and c2, 3a plus b minus 2. Now substitute these values in this condition. 2 on a minus b is equal to 3 on a plus b is equal to 7 on 3a plus b minus 2. So we get three ratios equal. Now equating the first and the second, comparing the first and the second. 2 on a minus b is equal to 3 on a plus b. Cross multiplying, you get 2a plus 2b equal to 3a minus 3b. On simplifying and carrying the like terms to the other side, a minus 5b is equal to 0. Now let's compare the second and the third. So 3 upon a plus b is equal to 7 upon 3a plus b minus 2. Cross multiplying, 9a plus 3b minus 6 is equal to 7a plus 7b. Now carrying the variables to the left hand side and constants to the right hand side, we get 2a minus 4b is equal to 6. This equation can be further reduced by dividing by a common factor, that is 2. So we get a minus 2b equal to 3. You can use any method to solve now these two equations, equation 1 and equation 2. Let's say substitution, because here substitution appears to be very convenient. From equation 1, a is equal to 5b. Substitute value of a in equation 2. So 5b minus 2b is equal to 3, which is 3b equal to 3 and b is equal to 1. And therefore value of a will be 5 into 1, which is 5. So we have found the values of a and b using the condition that is given, that is this pair has infinite solutions. So we use the condition for infinite solutions and then found the values of a and b. Here is another question of similar type. For which value of k will the pair of equations have no solution? So we have to find the value of k using the condition for no solution, which is a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. Substituting the coefficients of x, y and also the constants, 3 upon 2k minus 1 is equal to 1 upon k minus 1 is not equal to 1 upon 2k minus 1. Now comparing the first two ratios, 3k minus 3 is equal to 2k minus 1. Rearranging the terms, we get k equal to 2. Now compare the second and the third. So 1 over k minus 1 is not equal to 1 over 2k plus 1. So 2k plus 1 is not equal to k minus 1, or k is not equal to minus 2. So for these values of k equal to 2 and not equal to minus 2, this equation will have no solution. We will do some word problems now. Read the question. Yash scored 40 marks in a test, getting 3 marks for each right answer and losing 1 mark for each wrong answer. Had 4 marks been awarded for each correct answer and 2 marks been deducted for each incorrect answer, then Yash would have scored 50 marks. How many questions were there in the test? Now the test has, say, some n questions. Then Yash has answered some of them correct and some of them wrong. So let number of right answers be x and number of wrong answers be y. So the total Number of questions in the paper is x plus y. According to the first condition, if 3 marks are given for each right answer, the number of right answers are x. So the marks he will score for the right answers is 3x. And for each wrong answer, he loses 1 mark. And the number of wrong answers is y. So because he is losing marks, it is negative marking, there will be a minus sign. That means these negative marks given for wrong answers are going to be subtracted from marks obtained. So 1 into y will be the total marks that he lost by answering questions wrong. So 3x minus y will be equal to 40. Likewise, you will get the other equation. Had 4 marks been awarded for each correct answer, then he would have got 4x. But at the same time, there are 2 marks being deducted for each wrong answer. Then the total marks deducted will be 2y. So 4x minus 2y equal to, then he would have scored 50. So these are your 2 equations. You can solve them by any method that you find convenient, cross multiplication or elimination. I leave it to you. Let's go to the next question. Let us do this problem, which is based on speed, time and distance. Places A and B are 100 kilometers apart on a highway. So say this is our highway. A and B are 2 points which are 100 kilometers apart. One car starts from A and another starts from B at the same time. If the cars travel in the same direction at different speeds, they meet in 5 hours. If they travel towards each other, they meet in 1 hour. What are the speeds of the 2 cars? So we have to find the speeds of the 2 cars. Let us take our variables. Let speed of one car be x kilometers per hour and speed of other car be y kilometers per hour. So if both of them start at the same time and move in the same direction, they meet at point C after 5 hours. So let's say here is the point C where they meet. So time taken by the first car that starts from A to reach C is also 5, and time taken by the second car to travel BC is also 5 hours. We will form the equation in distance. So let's find the distance traveled by first car. Distance traveled by first car when they are moving in the same direction will be equal to AC. And we know that distance is equal to speed into time. So speed of this car is x and the time taken to travel from A to C is 5. So 5 times x. Similarly, we will find out the distance traveled by second car. That will be BC when moving in same direction. So that will be speed into time. Speed of the car is y and the time taken is again 5. So 5y. On the diagram, you can see very clearly AC is equal to AB plus BC. So we substitute these values that we have found. AC as 5x, AB we know it is 100 kilometers and BC is 5y. Rearranging the terms and reducing, x minus y is equal to 20 is the first equation. Now we find equation for the second part. If they travel towards each other, so this is AB, two cars start from A, B respectively, they are moving towards each other. So let's say they meet somewhere over here. So this is the point where they meet. The time taken by the first car to move from A to C is 1 hour. Time taken by the second car to move from B to C is also 1 hour. So again we will find out the distance travelled by each car. Will be equal to speed into time. The speed is x and the time taken is 1, so that is x. Similarly, distance travelled by second car is equal to BC, and that is equal to again speed into time. So that will be y into 1, that is y. This distance is AC. So from the figure you can see AC plus CB is equal to AB, and we know that AB is 100 kilometers. So AC is x, CB is y, and AB is 100. This is our second equation. So we can solve the two equations and get the speeds of the two cars. Here is another problem which is based on area. The area of a rectangle gets reduced by 9 square units if its length is reduced by 5 units and breadth is increased by 3 units. If we increase the length by 3 units and the breadth by 2 units, the area increases by 67 square units. Find the dimensions of the rectangle. The dimensions of the rectangle are length and breadth. So let length be x and the breadth of the rectangle be y. So we can write area is equal to length into breadth. So area is xy. This is the original area. Reading the first part of the sentence, if the length is reduced by 5, then the new length will be, I am denoting the new length by L dash, new length will be x minus 5, and the breadth is increased by 3, so the new breadth will be y plus 3. So our new area A dash will be equal to the new length multiplied by the new breadth, that is x minus 5 multiplied by y plus 3. Then the area reduces by 9. If we do these changes to the length and the breadth, then the area reduces by 9. So the new area is 9 less than the original. So x minus 5 into y plus 3 should be equal to x y minus 9. Reduce it to the standard form. We get xy plus 3x minus 5y minus 15 equal to xy minus 9. Xy term gets cancelled. The equation reduces to 3x minus 5y minus 15 equal to minus 9, which is 3x minus 5y equal to 6. This is our first equation. We get the second equation from the second part of the question. If we increase the length by 3 and the breadth by 2, then the area increases by 67. So new length will now become x plus 3. This is new length. New breadth will become y plus 2. So the new area is new length into new breadth, which is x plus 3 into y plus 2. According to the question, the new area is now 67 more than the original area. So substituting here, x plus 3 y plus 2 equal to xy plus 67. Now we have got our equation. It needs to be reduced to the standard form, so we multiply xy plus 2x plus 3y plus 6 equal to xy plus 67. xy and xy gets cancelled. This will be 2x plus 3y equal to 61. So here is our second equation. The first equation was 3x minus 5y equal to 6. Solve these two equations by any method: elimination, substitution, or cross multiplication, and find the value of x and y, which is to be written with the unit, because x is length. So whatever answer you get, you have to write down in the units which are given in the question. In this particular question, no units are given, so you will write down units. With this, we come to the end of this video lesson. Your assignment for today is exercise 3.5, question 1 and question 4. In the next class, we will learn how to reduce complex equations to their standard form and then solve. Goodbye.